Ever wondered how artists like MBGcore create their awesome ragdoll physics? Me too. That's why I did some digging. Turns out, the magic source is a software abandoned by its developers in the early 2000s. A software named Endorphin. In this video I want to do two things. I want to explain exactly what Endorphin is, why it's amazing, and how you can get started utilizing its AI-powered ragdoll dynamics in your Cinema 4D projects. What is Endorphin? Endorphin is abandonware animation software from the early 2000s. Back then utilized mainly in advertising and video games. It uses something like AI, for a lack of a better word, to generate ragdoll physics. Think characters dynamically falling, getting hit, reacting to forces like explosions. All without keyframes and based on behaviors defined in Endorphin instead. This software was most notably used to generate those super realistic falls and stumbles in GTA 4, all calculated in real time, responsive to each individual situation, truly groundbreaking in an era where canned animation was the norm. The developers of Endorphin, a UK-based company named Natural Motion, abandoned it, and most people forgot about it. But 3D artists like MBGcore use it in modern workflows and prove that Endorphin is old, but certainly not outdated. Even though the software has been discontinued for 20 years, with the right workflow, Endorphin yields impressive results and is a relevant tool for 3D ragdoll animation even today. Of course, the UI is clunky and the communication between Endorphin and Cinema 4D is not natively intended and can get difficult at times. That's why the typical workflow works by importing the animation as a skeleton from Endorphin to Cinema 4D and then painstakingly manually reweighting it to another mesh. And there's probably nothing I hate more than weight painting. So instead of doing that, I came up with a drag and drop bridge between Endorphin and Cinema 4D, outsourcing the pesky weight painting of meshes to Mixamo's auto rigger. This way there's no manual reweighting, no re-rigging, just a clean, retargeted motion straight from Endorphin to Cinema 4D in minutes. This solution is what I would like to show you in this video. I'm offering a sample file, including my Python scripts that largely automate the process on my Gumroad. Link in the video description. Purchasing the sample file helps me develop and improve these workflows. If you'd rather build it on your own, I'm also explaining the logic behind it in this video if you want to tinker around yourself. In either case, you will be able to use the extensive motion library created by the Endorphin community. Before we look at the workflow click by click, let's take a look at the core problem and how we can solve this problem. What you see right now are two rigs stacked on top of each other. In green, we have the standard Endorphin character rig, as you will export it from Endorphin after having created your Endorphin animation data. And this rig will contain the animation as keyframes on each joint. In pink, we have the standard Mixamo rig, and after auto-weighting your character mesh, the character mesh will be exported from Mixamo's auto rigger with this rig, and this rig will be what ultimately drives your character mesh. So essentially the problem is, how can we make these two very different rigs communicate with each other? Because you see the amount of bones is different and the proportions is different. So we are trying to take the Endorphin animation data and drive the Mixamo skeleton with that. And this Mixamo skeleton in turn will drive our character mesh, resulting in our Endorphin animation driving our character mesh without having to manually weight it. And recent versions of Cinema 4D offer an elegant solution to this problem: the character solver tag and the character definition tags. And basically we have a table that outlines a skeleton structure in terms of joints and the nesting of these joints. And on the Endorphin rig And on the Mixamo rig, we define such a table. So we say, hey, on the Endorphin rig, this is the hip joint. On the Mixamo rig, this is the hip joint. And we do that for all of the joints. And once we do that, these two can communicate with each other, and we can say, oh, if this is the Endorphin rig's hip joint and this is the Mixamo rig's hip joint, I can just copy the movements from this Endorphin hip joint and move the Mixamo joint. And essentially that is what the character solver tag does. Once you have such a character definition tag for both rigs, you can make them communicate with each other, and in turn the Mixamo rig can receive animation from the Endorphin rig. I'm guessing ultimately you will want to make your own Endorphin animations. However, in the beginning it can be helpful to have access to some animations from people who are very proficient in the software. And while researching this whole Endorphin to Cinema 4D rabbit hole, I came across these groups of people who make Endorphin animation based videos in GTA San Andreas. And this scene seems to have kind of died around 2015. And one of these creators, called Spirit Edits, apparently stopped making these videos, and he's offering all of his Endorphin animations for free download in one download file. There will be a link in the description to the video where that download link is. So if you're interested, that is where you can get a bunch of really good animations immediately as a starting point to play around with this workflow. Let's take a quick look at how to export Endorphin animation data for it to properly work with our Cinema 4D workflow. So I have a sample file here from Spirit Edit's animation pack, as mentioned just previously. And in this animation, I select the character I want to export. I go to export. I define a name, and more importantly, in save as type, please select FBX 6.0. And in this window, please leave scale as is, export environment, I uncheck it, start frame, end frame, make sure it has all of the animation data you want. And in frame rate, select your target frame rate in Cinema 4D. For the target reference character, it's important you select audio motion too. And in the target character rig setup, you can leave everything as is, hit OK, and you're done. This is how you auto-rig a character mesh in Adobe Mixamo's auto-rigger. You just drop your character mesh into the dialog box. It should be FBX or OBJ format. After that, Mixamo will process your character. Once your character is processed, you should see a quick overview of the character, and in this overview, before you hit next, you have to make sure that your character is oriented in front. And once you do that, make sure that the skeleton LOD is skeleton 65 for best results with the Endorphin workflow. And now place the circles on the corresponding parts of the body of the character mesh. So the chin on the chin, the wrist on the wrist, the elbow, the elbows, etc. Once you have defined all of these key joints, you hit next. And now the auto-rigging algorithm automatically rigs your character mesh, and that is how we save the pesky weight painting, because now Adobe Mixamo is doing that for us and is saving us a lot of time per character mesh you do this for. So once the upload is processed, we get a quick overview of the meshed character, and we can quickly check if it moves as it should, and with exception of the groin, everything looks fine. So I click next. Then we proceed with this character, and we can't really export it like this because our Endorphin animation is in T-pose. So what we have to make sure now is that our Mixamo rig also is in T-pose. So in the search bar we put T-pose, and then in the animations selection we can look at the animations, and there is a T-pose we can select, and then it will be applied to our character mesh. And then in the export settings, do FBX, make sure the FPS, frames per second, matches your desired frame rate in Cinema 4D, the width skin, and then you can export it. And now what we get is a FBX file which contains our character mesh in T-pose with a Mixamo rig. Let me show you how my template file can save you a lot of time and frustration. So this is how it looks when you load up the template file and you have a character solver tag which transfers the motion between the two skeletons. It does this through character definition tags. We have one for the Endorphin skeleton and we have one for the Mixamo skeleton. And the Endorphin skeleton is set as the source, the Mixamo skeleton as the target, and that is how the motion is transferred. These tags working by having this table with joint structures, and we basically define where the hip is for each skeleton and where the bicep is for each skeleton. And once we do that for all the joints that we want to transfer the motion for, they can communicate with each other. So you don't have to do that painstakingly, manually every time. I ship my template file with 2 presets, one for each rig type. So now let's load in the Endorphin rig. As we created it in Endorphin before, we see it here now. And we have a skeleton named hips, and we have the animation as keyframe data, as we can see below. Once we hit play, we can see the animation play back, and it looks as intended. Great. Now we take this skeleton named hips, and we drop it into the red null named drop Endorphin rig here. And now if we open up the joint structure, and let me tell you that these Endorphin rigs, they sometimes have deviations in the naming or in the joints. And that's why I created a script to normalize all these different Endorphin rig types. So basically we select the skeleton, execute the script, and as you can see, that renames it. And it has one naming convention that I came up with that works with the character definition preset. So once we've renamed it, we can now import our previously in Mixamo auto-regged character. So this comes with the mesh in T-pose and a Mixamo rig that drives this character mesh. Now we can take all of these character mesh files and just drop them into the character mesh container. This doesn't serve any purpose, but just cleans it up a bit and keeps it neat and tidy. Now we take this skeleton, Mixamo rig hips, check that it actually drives the mesh, and then we drop that skeleton into drop Mixamo rig here. And now we click the corresponding character definition tags. We load the preset. So if I'm opening the character definition tag for Mixamo, I load the Mixamo preset and hit extract skeleton. Once I've done that, I do the same thing for the Endorphin character definition tag. Load preset, click the Endorphin preset, and extract skeleton. Now we should be able to transfer the animation from the Endorphin rig to the Mixamo rig, and the Mixamo rig drives the mesh. So now we should have the animation of the Endorphin skeleton on our character mesh, and we can see it works very nicely without any weight painting, just drag and drop with a few clicks. We have saved all of this pesky weight painting work. Now we can also see that there is no keyframes on the Mixamo rig because it just receives all of the animation from the Endorphin rig. But we can also see that the toes are a bit jumbled up here, and that doesn't look nice. We want to fix that, of course. And that is what we will do next. So we can see in frame 1 it looks great, but if we go a frame further, we can see, okay, from frame 1, it's jumbled up, and for some reason just the endorphin rig points down, and that's why the toes are messed up. And we fix that by baking the endorphin animation into the Mixamo rig. And we can't just go in search and bake it for some reason. I can't tell you why that doesn't work, but you have to go through the keyframe timeline editor, Shift F3, go into functions, and we have to bake it from here. We open this dialog, we untick create copy, and we untick clean tracks, otherwise it doesn't work. We make sure all the frames are there, we click OK, then it bakes the animation. And now we can see that our Mixamo rig, it has all the keyframes. So it doesn't receive the animation anymore from the Endorphin rig, it now has the animation data in itself as keyframes. So how do we now fix these toes? Because the toes are still jumbled up on every keyframe. And the way we can fix that is utilizing motion clips. So we go to Animate and click Add Motion Clip while having the Mixamo rig selected. Create Motion Clip ticked. Bake Expression, Remove Included Animations, Create Pictures, all unticked. And now we go into Shift F3, and then we click this motion editor icon, and then we are in the motion editor. And over here, we now have this animation as motion layer 0, and we are gonna add a correction layer. So we click Mixamo rig hips, click add, and that creates another layer. I always rename it to correction layer, and the important thing is that empty layer, you have to drag it above layer 0. And what we can now do is we can layer corrections on top of that layer 0. So we click the joint we want to correct. In this case it's Mixamo right toe base, and we move the joint to where we want it. Not working. And the reason it's not working is the character solver tag is still enabled. That somehow overrides it, so make sure to disable that. And once we disable that, we should be able to correct our animation through motion clips. So we twist the joint, and voila, we can see the mesh is being affected. So we just move the joint where we want it, we keyframe it, we go one up ahead, and oops, it still looks weird. We, in this frame, also correct it, and then keyframe it. And what you will see now is that if we play the animation, the toes now are fixed in their position. So with just adjusting a few keyframes, we have affected the whole animation. We just correct on top of it. And let's just play this animation for a bit and see if the toe position still is fixed. Hit pause. Frame 1 it's jumbled now, but if we go ahead, it should be fixed. And what we can also try to do is we can try to, change the whole position of the skeleton by just adjusting the hip joint. And we can see that now corrects it on top of the toe correction, kind of. So now we are fixing multiple things and are adjusting the animation after we have created it in Endorphin. And what we can see now, even if we delete the character solver tag, we still have the animation on the Mixamo rig with its corrections, and that is because we hard-coded all of the keyframes into the Mixamo rig now. If you want to do it yourself without a template file, let me give you a quick run-through. So we start off by importing the Endorphin animation that we previously exported from Endorphin. And after that, we import our Mixamo rigged character mesh that we auto-rigged in Mixamo's auto-rigging tool. Now we see we have two skeletons in the scene and the Mixamo characters mesh. And again, we have all the keyframe data on the Endorphin rig, and we have no keyframe data on our Mixamo rig. To keep the scene tidy, I create a null named Mixamo mesh, and I drop all my Mixamo meshes in there. This doesn't serve a function, it's just to keep it a bit tidy. For the motion transfer to work properly, the Mixamo and Endorphin rig have to match up. So if that's not the case, we can fix that by creating a constraint tag under tags, rigging tags, and then we tick the transform option. Then we drop the Endorphin hips into the target, and then the Mixamo hips will align itself with the Endorphin hips. With the offset, we can do some more corrections. And then we select all children, keyframe it, and then we have secured that position as the starting position. Once we have done that, we can just disable the constraint tag, or we delete it. And after that, the two rigs should be aligned in the first frame, which is the reference frame we need to link them up. So I always create a null to hold my character solver tag. I name it retarget driver, and then I apply the character solver tag to it. In the character solver tag, we need to define a source character, that being our Endorphin character, and the target character, that being our Mixamo character. Now we can't just drop the skeletons into the character solver. We need to create character definition tags. And we do that on both of the skeletons, and we name it so that we can, tell them apart based on name, so we don't mix them up in some silly mistake. And once we've created a character definition tag for both the Mixamo skeleton and the Endorphin skeleton, we have to somehow define which joint corresponds to which. And through these tags, you do it through this table. And I recommend you build yourself a preset, so you only have to do this tedious job once. So basically you say in the Mixamo rig, this is the hips. In the Endorphin rig, this is the hips. And you do this for every joint. And then those two rigs can communicate. Now let's see what happens if we don't have the correct table or no table at all. We'll just extract it as is and see what it recognizes. It does a fairly well job with Mixamo by default. But for the Endorphin rig, it's a different story. So if we just extract it without having built a table that tells it exactly what is what, it only recognizes 11 joints, and we don't even know if it recognizes the right joints in the right position. So for hips, it recognizes hips, that's right. For head, it recognizes 2 joints, we don't want that. Same for the right toes. So it doesn't recognize most joints, and it doesn't recognize all of them correctly. So let's just see what happens. We see that the character solver tag is enabled. That is the case. And the animation is on the Endorphin skeleton. And now we open manager, we set reference pose after having extracted the skeleton. We do that for both. set reference pose, and now still nothing happens. We have to go into the character solver tag, and now we have to say what is the source character, what is the target character. We drop the Mixamo rig into the target character because it's supposed to receive animation, and the Endorphin character definition tag as source. And now the animation should be transferred, and we see it is completely jumbled up. Most joints are not receiving the animation and it just looks off, and that just is because the character definition tag table is not set up properly. So what you have to do is figure out which joint should correspond to which on the opposing rig. And if you'd like to circumvent all of this, feel free to click my Gumroad link below and go forward with my template file that is as easy as drag and drop and hit play in less than 2 minutes. In any case, I hope this tutorial could maybe introduce you to Endorphin, maybe could show you how you can finally use it in a simple way. I hope you took some value away from this, and I would love to hear your thoughts and comments, so please feel free to comment below if you like this and if you would like to hear some updates about the Endorphin pipeline or about my work. Feel free to subscribe.